This topic is Intro to Higher Order Polynomials. This first slide, can you identify the shape of each of these graphs by the degree? So let's talk about the first example. F of x equals 4x minus 2. The degree is 1. You remember the degree is 1. If you think about this as dropping the f of x and replace it with y, this is the slope, this is the y-intercept, this is a line. The second example in green, the degree is 2. So that's telling me I'm going to have a parabola. It's a quadratic function. Looks maybe something like this. Maybe opens up, maybe opens down. In this case, it would open up because the leading coefficient is a positive number. Example C. Now we're getting into a cubic function because the degree is 3. Our shape is going to be a snake. Our last one in the purple, our degree is 4. So that means we're going to have what we call a quartic function. And it's going to look like either a W or an M. These next slides, I would just like you to just listen and watch. You don't need to write them down. I think you'll get enough practice. So it's going to ask you to identify what is the leading coefficient and the degree. So here's a general function. The leading coefficient is the highest term's leading coefficient. This is the degree. So here are a few examples. No need to write them down. So the first function, the leading coefficient is negative 2. Its degree is 5. That degree tells me a lot about the shape of the graph, and the leading coefficient tells me its end behavior. The next example, the leading coefficient is 1. The degree is 5. That one tells me the shape is going to be a snake because the degree is 3. The last one, the leading coefficient is 14, and its degree, it doesn't have an x term. So that means the degree is 0. It is going to be a constant. It's actually a horizontal line going up on the y-axis, up 14, and then straight across. This graph explains our continuous functions, when they're continuous and when they're not. So this first graph is a snake. Notice it kind of goes up, comes back down, and goes back up. This is continuous. It is a polynomial. The second example goes like this, and then it has a hole, and then it picks back up again. This is not continuous, so it would not be a polynomial. The third example kind of has some very strong points here. It's not smooth, but it is continuous. It's also not a polynomial. So the definition of polynomial function is, it must be smooth with rounded turns. Graphs with points or cusps are not graphs of polynomial functions. Again, this last slide, don't need to write it down. These are called your power functions. Notice the difference. When I have a quadratic function here, there's my parabola. When I increase it to x to the 4th, still an even function. Just kind of widens it out a little bit here, but very similar in shape. Same thing goes when you have your odd functions, x cubed, or x to the 5th. Very similar in shape. When the n is even, they look very similar in shape. When n is odd, they look very similar in shape.